This is Benzene Clayton coming to you from the University of Pikeville, doing practice exam 6, problems 6 through 9, cutting straight to page 2 here, getting to the good stuff. Here we have in problem number 6, we have something about a sweet smelling, fruity type smell here. Esters are commonly perfumes and flavorings, and we see here in this answer choice we only have one ester present. Aldehydes and ketones, especially with benzene rings, also usually have a sweet smell, but that is another chapter. But here you can see we have an ester, and we can actually name this ester here. We have a pentyl. That may come up tomorrow. We have a pentyl acetate in this particular example here. This part of the molecule is always the acetate. Excuse me. I'm a little bit tired today if I mess up. I apologize ahead of time. Benzyne was out all last night, going crazy, going a little bit wild. So I'm tired on this Monday here, as all of you guys are probably tired yourself. Next one here, we have the beta-lactam ring. All three of these here are all beta-lactams. Let me circle that for you. And here, beta-lactam rings there. So that 1, 2, and 4 is the correct answer on that one. And what we're looking for is a 4-membered ring again. That is a cyclic amide. The draw right in the middle there. The 4-membered ring with the nitrogen and the carbonyl within the ring. So if we have something like this right here, with the nitrogen in the ring but the carbonyl outside the ring, like that one there, that does not count as a beta-lactam ring. Next one here, we're looking for lactones here. Lactone means that we have a cyclic ester. Here's the only lactone in this particular drug molecule. So we have one. I actually don't like this format of questions. If I ask this question again tomorrow, it's probably going to be phrased more like this one right here, where I give you a set of different drugs and you have to pick out the lactone type drugs, just like you've picked out the beta-lactam rings here. In this case, now the lactone doesn't have a size to it, so you don't have to worry about that. Okay, starting in, most of the chapter here is composed of just a bunch of reactions. Here we see these are a type of very short retrosynthesis problems here. And this one here, when you do a retrosynthesis, you always observe first the starting material, then the product. You observe what functional groups have changed. We had a carbonyl here, now we have a nitrogen. And you also take a note, take an accounting of all the carbons. This carbon was added. We also had, of course, the functional group of a nitrogen being there. But we could go to the answer choices here and try to eliminate things based on the one carbon being there. A little bit tricky, but B would not be a possibility because acetic acid usually doesn't add in a lot of cases unless we're adding an ester group to it. But that's a case-by-case basis. You just have to look at it. So we observe here two problems with, two answer choices that have pointed to the wrong one, have a amine compound in both of those. That could be a source of the nitrogen right here. In letter D here, rather, that does not have a nitrogen, so we can cross that one out. If there's no source of atoms, then you can refer to the your elimination process in that case. So it's either A or C, and here A is a situation where we add in some kind of base. We have to reason out what is a base going to do to this compound as far as we can tell it just attacks that, and that would result in something that looks like this here. And that's kind of crazy, because what in the heck is this methylamine going to do to that? Absolutely nothing. That is a crazy answer. So C is the answer choice here. And what happened here is, in the reaction, the amine compound attacked right there, and we get this this here as an intermediate, and then this sodium cyanoborohydride comes along and attacks that, and we get a reduction to form this. Okay, and that's it for problems 6 through 9.